Thanks, Don.
Go ahead.
This is 29th June SIG Node weekly meeting. Looks like we have a pretty packed agenda for today. Let's kick it off with the PR and issue update. I believe it is going to be Sergey or Ilana.
Yeah, sorry, I didn't prepare this thing yet. I can go in the end of the meeting.
No problem.
Sounds good. From the bug perspective, we squashed a lot of bugs. I don't know if you want that update.
Yeah, feel free to go ahead.
I think what was the specific numbers? I posted them in the Slack as well, but we definitely closed over 100 bugs when we squashed bugs last week. So thanks everybody who helped out with that. Let's see, what are the exact numbers? And Sergey made some graphs too, which were really great. Yes, we closed 136 issues and we updated over 200. So I should say we updated over 200 that were still open. I don't think that counts all of the ones that we closed as well. So we did a lot of work. So thanks everybody who participated in that.
That's amazing. Thanks, Ilana, for organizing this. This was, I think, a great event. And we saw a lot of new faces and a lot of participation. That was great. Okay, next one is you, Ilana. Do you want to go ahead with swap update?
Oh, it's me. I thought that Vinay was in front of me. I think that I just need like final approval. Jordan finished up API review and I'm just pushing out some stuff to fix nits. But other than that, I think it's basically good to go. Seth reviewed the implementation a couple weeks ago now, I think, and there were no really big changes. There was a renaming thing that needed to happen, but currently the PR end-to-end jobs for both Ubuntu and Fedora are working, and so I think it's good to go.
Cool, sounds good. Is there anything else, like any support or anything, any review requests you need from anyone?
I think it's just final approval at this point.
Yeah, so I think Mernal and myself were drafted as approvers for this when we did the CAP review, so we'll do that this week.
That's perfect.
Yeah, Derek, if you could take a look as soon as you feasibly can. I know there's a lot of folks who are kind of chomping at the bit to be able to test this, and until it merges, it's hard to test. So basically, the sooner we get it in for like alpha or beta releases for 122, the better.
Yep, we'll do.
Yep.
Cool. So next one again, I think it's you, Ilana, requesting node approver.
Oh, wow. It's just the whole agenda is me today, huh? I have requested approver access. I hope that's okay with folks. Somebody pestered me saying, you have reviewed something like 500 node PRs. Why are you not an approver? So I said, okay, I will apply. I think I'm waiting on Don and some of the folks from Google to take a look at the request.
That sounds great. I think other than the bug scrub, like I think everyone knows about the bug scrub, but there's one more thing that I'd like to add, which a lot of people might not know. Ilana has been leading and facilitating 1.22 leads cohort training group, which I've had the opportunity to experience kind of firsthand. And that has been kind of a great learning opportunity for me as a representative from SIG Node, and there are other representatives from other SIGs as well. And this is part of the contributor ladder growth program. So if people want to sign up for like the following releases, it'll be kind of a great learning opportunity. So thanks, Ilana, again for that.
Oh, yeah, no problem.
So I think one of the things we'd like to do, Ilana, out of this request is to more concretely write down like a growth path for SIG Node. Others have expressed interest as well. And so one of the things I wanted to do was get the existing set of approvers together to write down maybe their path to approver and maybe some common criteria that we can evaluate these things going forward. And then hopefully we can meet this week and then proceed from there. But like Swati, I think everybody else appreciates all your effort in the SIG, and yeah, hopefully we can find a path forward.
Yeah, so we don't have like the clear written requirement. Explicit side is being issued in the past. So this is why sig-node and also work with some other SIG have some like some written, but it's not very clearly, because one issue we realized in the past, it is so some of the SIG, big SIG, large SIG, like the sig-node, large enough, and approver means 3 different roles, and so there's no final granular definition. So that's why this is missing. So recently, Elena and Phil Fox approach ask approver. It's not just Elena, and some other people also ask for. And so then we realize there's the time for us to retain those kind of things, make more defined by the existing of the SIG group approver. And then we can come back, because we think about the a few folks, including of Elena, on the path toward that one, and we should make that more clear. And so we have like constant standard for the community can follow, and also it's written down publicly, and then the people can follow, and they can really just self-exam, say where they are. So just yeah, so we should do this. So Derek and I just before the meeting say we should address this problem, and hopefully this week we can get together to start.
Yeah. And then just in transparency, one of the concerns is that Kubelet intersects with storage and networking, and to some degree scheduling for what it embeds. So we just have to work our way through that sensitive to those SIGs. So we'll look to get that written down, and yeah, so thanks for stepping forward, Alana.
Yeah, one of the things that I just linked in the chat, unfortunately, there's just, you know, there exists a contributor ladder and path and whatnot, but the requirements to become an approver according to the project are, I think, not aligned with what a lot of the larger SIGs actually expect, because they're like they list the requirements. It's like, oh yeah, if you've like reviewed 30 PRs, you're good to go. And if you've been a reviewer for 3 months, and I recognize that for certain chunks of code, that's really not sufficient. So
yeah, I think yeah, we'll try to get something more granular or appropriate, and actually would like everyone in the SIG here to give feedback on it as well, right? We have to find a way to balance these things. So for those approvers on today's call, I'll look to set up some time, and then maybe next week's SIG meeting we can review and then evaluate both Alana's proposal and any others who want to come forward with that community standard. And so thanks again, Alana, for helping us to get this clarified.
sure.
Okay, so let's move on to the next item. We have Vinay. He wants to talk about in-place pod vertical scaling cap.
Yeah,
Do we
hi.
have you?
Yeah.
Perfect. Go on.
So over the past week, I think the core implementation, I got it mostly completed. The only piece that remains in the core implementation is changing the scheduler and resource quota accounting to use max of requests and resources allocated, where previously in the previous iteration of the design, we had it at resources allocated. The new piece that came in, besides the change to switching from spec.resources allocated to status.resources allocated, is the resize, which was easier than I thought. So it is working, and the good thing is that we have the E2E test, which is pretty comprehensive from the last iteration of the design. That one, I think Wang Chen is adapting to cater to the updated API, and it looks like she's making great progress on that. So we have a certain degree of confidence with the automated E2E tests from the previous iteration that we can count on, rely on for quality of the changes that we have made. That said, I'm planning to get the scheduler RQ changes looked at closely because I don't want to just port this. I want to look at it and make sure that it makes sense with the Macs. And was wondering if Lanta, I know Runal had a comment about CRI. I'm wondering, I don't know if Tim Hawkin got a chance to look at the API changes. I'll ping him again. He mentioned that he's got me in the queue. I just don't know how backed up he is. I'm wondering if Lanta had a chance to look at the core implementation. Most of this is a port from what David Ashpole had already looked at pretty closely. I kept the code structure, the key piece of how the kubelet processes changes and how it's plumbed down to the CRI and how the container status is queried, and then the API status is generated for pod status. They mostly remain the same. The new thing is the checkpointing code, and I put that under status. So the key thing to look at closely is, does that make sense? Does the code look good? Is there something that we could improve on? And then the other thing is the resize. So just wanted to see where Lantau is at. We have.
Yeah, I'm here. Yeah, I will take a look this week. Last week I checked it. I don't know whether it's ready for review because you wrote "do not merge work in progress" in the changed PR title. So I thought that it's not ready for review yet.
Yeah, I didn't want it to be considered for merge ready until it's pretty close to ready. I'll remove those labels now because
okay.
I want to remove it after I get done with the scheduler and resource quota changes. Although it's pretty small, I want to make sure that I do this by hand, as in manually, to make sure that I don't miss anything. Or so this was already done in the last iteration. We switched from using requests because requests can now change. Previously, requests was immutable. So when you create the pod, it is what it is. So now we have to do a max of requests and resources allocated. That's what we decided to do. And I think it is reasonable. It might even be simpler. I'm planning to do that in a couple of days. I've been backed up with other things, so haven't gotten to this. I know time is running short, but I think the rest of the code is ready for review.
Okay, yeah, I will take a look this week.
Okay, thank you very much. That's all I had, unless anybody has any questions for me or Wong-Chin. Oh, one more thing we were wondering, should we create a separate direct PR for the E2E tests from Wong-Chin to KK, or should it go through my PR? What is the preference for sig-node?
Usually you need to test that it actually is working before you can merge the PR. So you probably want the E2Es in your PR.
E2E is part of the PR, part of my main PR then. Okay, we'll do that. I just wanted to make sure that her contribution to this doesn't just get merged with mine and it stands out. That's all. She gets credit, I mean.
Yeah, you can put the person's name in the commits, so or do co-authoring, right. So it shouldn't be an issue.
Okay, we'll do that. Co-authoring. Okay, thank you.
Thanks, Vinay. Next, we have Daniel. He wants to talk about auto system cube reserves, system reserves. Do we have Daniel on the call?
Hi, yeah, I'm here. Yeah, I think I would maybe need like 10 minutes or so, explaining a little bit about the background, if there's time for that.
Sure, we do.
Let me quickly share my screen, if it's possible. I think the host has disabled the participant screen sharing at the moment.
Yeah, I think she needs to add you as co-host.
Oh, okay. So yeah, while that's being done, I have opened a feature issue, and it is about reserving the the cube reserved and the system reserved memory, basically a new approach of doing that. Okay, now I think I can share. Hopefully you can see my screen now. Okay, I have opened the issue here. I've described a little bit about it, but I want to give you a background about on it. Yeah, first off, hi there. I'm Daniel. I work for SAP. I work on Gardener. It's an open source Kubernetes as a service, and yeah, because that's the first time I'm presenting something here, I wanted to say hi here. Okay, let's jump right into it. Currently, setting cube and system reserved is basically a static configuration, right? In the configuration file, cube reserved, system reserved, and it's typically done prior to the kubelet startup. And updating cube and system reserves requires a kubelet restart. And how it is typically done for Kubernetes, or managed Kubernetes offerings, is they calculate the cube and system reserved based on the machine size. GKE is apparently doing it Azure OpenShift. There's an enhancement open, and also Gardener is doing that. What we have observed is that calculating reserved resources prior to the kubelet process starting is an approximation in the best case. And we have had some troubles because on particularly busy clusters, we have seen that the resource reservations were too low. And for mostly idling clusters with not a lot of pods running on it, the resource reservations were too high based on the machine size calculation.
Can I ask one quick question, if that's okay, Daniel?
Yeah, of course, always.
This is Derek. So is the machine size heuristic based on just the instance type, or is it also based on, is the pods per node? Is it just choosing the defaults from kubelet for that, or are you also tweaking like your desired pod density?
So I think there are different kinds of calculations out there. There are some that also considers max pods, right?
Yeah.
But I'm currently in the process of finding a better way to do that, at least for Gardener. And so, yeah, that's what the issue is technically about. And I also wanted to ask, of course, how are your experiences using this heuristic based on the machine size or max pods, for instance? Yeah. Did that answer your question?
Yeah, I guess so. I was just trying to, some folks, you know, might tune for particular workload characteristics, I guess. And so like, if you are trying to bin pack your nodes, or you're trying to, you know, plan your nodes for 20, 40, 80, or just the pods per core calculator, I think is what 10 pods per core right now is the default in kubelet. I just wasn't sure if those other knobs were going into heuristic beyond either RAM or CPU.
Yeah. Okay.
Which is fine. That's fine. Go ahead. Sorry.
Yeah, that makes sense. So just real quick, why is that even important? Consequences of over-reservation. Over-reservation leads to lower node allocatable. That has effects on scheduling. All of that, in the end, will increase your costs, lower the utilization, as you were mentioning regarding bin packing, for instance. The bigger problem that we have faced is under-reservation. For a CPU, I'm just mentioning CPU and memory here, but I think it's similar for other resource types. CPU, here the Q-pods C group, for instance, has too many CPU shares. And in case there's a CPU contention, there's a risk of starving all the other processes basically in addition to the kubelet and the container runtime. And that has led in our cases to some node instabilities. Maybe something like plaque is unhealthy. So yeah, it can surface in various ways and it's hard to debug and to know why. Memory, the major issue that we're seeing here is when you under reserve memory is that the global OOM, Linux OOM killer hits before the C group level OOM killer. So basically that the node is running out of physical memory before the QPOD's C group limit is hit. And that has some bad implications because then almost any process on the host can be terminated. Yes, it's influenced by the quality of service class. Yeah, but we have also seen here problems, also OS deadlocks due to when this global out of memory happened. So ideally, of course, the C group limit on the QPOD slice would hit first before there's a global out of memory happening. So that's the goal for the memory, setting the right limit for the memory here. Yeah, just to show it real quick. Usually we under reserve, so the C group memory limit is quite high actually, almost at capacity level. I've indicated that here. It's a physical capacity level. And the only thing I want to show here is that the memory limit on the QPOD C group is not at all reached yet. There's a lot of capacity left technically, but the host itself is almost running out of memory. So even though by adding a little bit of memory usage to, for instance, QPODs or any other OS process, the limits on the QPOD slice are not hit, but before that happens, the whole machine is running out of memory. And that's typically what we are seeing when we under reserve memory. And that's problematic. 1 second here. Yeah, what drives required resource reservations? Any process outside of the QPOD C group. And we have seen that it's mainly the kubelet and the container runtime. Guess that makes sense. And also including the container runtime shim processes when using containerd, for instance. And now then the question is, what drives the kubelet and container runtime resource usage? What we have observed is the number of pods running currently on the node. I think that also makes sense because the kubelet and the container runtime have to handle more pods. And there are also additional container runtime shim processes for each pod. In addition, a big influence is the kind of workload running or deployed on the node currently. And that's something that's very difficult to predict or impossible to predict if you're running a managed service, because yeah, people can deploy any kind of workload on it. And we are unsure exactly why that is the case. I think that would need more deep investigation to why exactly. But we see that across a lot of clusters. Showing you here the pods deployed, just from 10 to 100 pods. You can see here that basically the CPU and the memory requirements for Docker, the container runtime here, and the kubelet are increasing almost linearly. So that's one thing. And the second is the more significant one. Sorry, there's a lot going on in here, but I just want you to check out here on the side. So technically what we did is we reproduced the issue. We created a node with exactly the same configuration, the same operating system size, but once with a real world applications running on it, some real workload, and the other one just 110 pods, same amount of pods, running some some sleep, so doing nothing essentially, and then comparing the required CPU and memory for the system slice, and in particular the kubelet and the container runtime. What you can see here is in this test cluster, Docker, for instance, is using 2.6 GI, and the kubelet is using 120. And comparing that with the real world usage that we are seeing, there it is almost more than double. It's 6 GI and 300 MI for the kubelet. Even though we are running the same amount of pods, it's the same operating system, it's the same machine size. So yeah, the workload has some influence on it.
I just had a curiosity, even under real world workload, was that like 110 pods that were under like churn, like pods stopping and starting, or new pods getting scheduled, but just like a constant 110 pods at work? Or
That's
is it,
sorry, go ahead.
Or is it, did you schedule 110 pods who were actually doing function and then just kind of see what happened? I guess I'm curious if any of this memory growth is a consequence of kind of entropy in the system from stopping and starting many other pods.
Mm-hmm. This was actually a long-running node. So this is a node that hosts, in this particular case, control planes of other clusters. And
okay, so this is just Gartner itself hosting the user clusters. Cool. Right.
Yeah. So this is long-running stuff. And these are basically the numbers we're seeing there on multiple clusters. And yeah. So finally to the proposal or the feature request. Basically the main idea would be to, because we are seeing all these problems, try to find a better way to, or a different way, how to reserve resources, especially for memory and CPU, that also takes into account the current usage on the system, because it's really hard to predict, at least for us, what kind of workload is running on it, how many pods, and then how much CPU and memory is going to be consumed by that and has to be reserved. Yeah. Ideally,
just one other question to clarify. Sorry.
Mm-hmm.
The real world system and the test system, they were the pod specs were they similar in terms of both the init container and the actual container spec, except that it's not doing any work, reserving the same amount of memory, but I just want to make sure the init containers were not missed.
No, I think they were missed. So okay. In this particular case, there were no init containers, for instance, in there. These were really plain load test pods. But yeah, it's definitely not a very comprehensive investigation that I would can comfortably say everything is covered.
Okay, I'm not drawing any insights. I just want to make sure that we are aware of it. That's all.
Yeah, good point. So yeah,
I have a question. For this non-pod, non-qubit pod C group processes, is it so what you are trying to parse the C groups hierarchy by yourself?
That's
or from where you get the actual usage in your proposal.
You mean in this slide here? In this slide here?
No, in your proposal. So if I read your proposal correctly, is what you are trying to adjust the values of the system and cube reserved values inside kubelet based on information which is right now not known to kubelet. So my understanding is what you need to parse the rest of the C groups hierarchy inside kubelet to adjust those values. Is it so?
Alexander, you're right. Yeah. So maybe we let Daniel finish the proposal, but you are absolutely right. So so we consider Daniel, I post what we discussed in the past, and but given today's quality of the services tree structure, you what proposed have to pass down to the C group on the disk on the file system, file system. So that's make the things more complicated. But we can finish this, and then there's some things that we need to consider.
Yeah, definitely. I mean, there are a lot of things to consider, and the first thing I definitely wanted to ask first is, what are your thoughts on it? Is that feasible? Do you have similar problems? That's the main thing. I mean, I come to that in a second in the question part, but that's basically it. Regardless of the actual implementation, because I haven't detailed that out, I first wanted to ask, I'll just jump here, or am already.
I have a couple of questions, Daniel, if it's okay.
Mm-hmm.
You have the, just trying to understand the bounding of maybe what you have explored or haven't explored, like in the setup for Gardener, is the kubelet and container runtime under system slice or in a separate C group slice from system?
They are currently they're not following the recommended C group setup at the moment. They are both under the system slice, so yeah, they can count to it. And
to be fair, I think that's perfectly fine. But we, and like here at Red Hat, we were doing the same, right? And while I think in the community talked about ways of splitting them out, I think very few have done it in practice. So that's good. And then the other question I was curious about is if you've done any testing on what happens if you have the enforce node allocatable feature turned on to be enforcing on the system C group. So like right now, there's nothing actually inducing pressure back on system slice to force reclaim because it's unbounded. And there is a knob that lets you set a bounding limit, but it's kind of risky to set because you don't really know what the killer is going to do when it gets to pressure on system slice, but it would naturally put pressure. So I was just curious, like if you have explored either bounding the kubelet and runtime in a separate C group where node allocatable is enforceable on that C group and seeing different results, because that was one question. And the other question was, Mernal and I were chatting a little bit in the background, but one of the reasons we at Red Hat have been so motivated to look at C groups v2 is we think we would see improvements in this space. And so I'm curious if SAP has explored that at all.
We are exploring first, I would say, going to the recommended C group setup. And then basically enforcing the node allocatable on the separate on the system slice and then also on the runtime slice. But currently that's not being done yet because it's just, as you see, the problem is just that the memory and the CPU requirements are so vastly different that at least I am not feeling very comfortable on enabling that. Because yeah, stuff in system slice might getting killed, as you were saying. Yeah, so I have not done a full-blown investigation on adding, yeah, node allocatable.
Is that something we've ever evaluated? I can't recall if we've ever tried to parent our runtime and kubelet in a separate C group and turn it on or not in our own preference. But am I off that nothing's going to be putting pressure on that to force reclaim, that the numbers will just grow? I don't know.
Yeah, I think maybe Seth would know, Derek, if we explored that, but he's not on. And yeah, but I agree with you.
So the number could be grow until based on your system level of those config and the trigger sys-oom. So then the sys-oom wants to trigger the whole node performance and also which one, even we have the oom score set, right? All it is the best effort because when kernel look at kernel will, because the kernel will also try to prevent of the kernel deadlock, which is really bad of the system. So they will try to pick up whatever process based on available of those kind of things. And as explicitly say, this is not killed. Even like the newer kernel version, there's not allowed to not like the mark certain process not killed, but you could still. So then they will basically, it is just random pick up some process has some range of the score range, and then we'll think about which one have the most can reclaim the memory most, and then they will kill. So you make this a whole system and predictable, performance and predictable, and at the same time will be random. So all those like the Kubernetes, the priority class won't make sense here. What's the scenario? Good part it is right now, when we kill, we can detect in Kubernetes. We can detect, then we will kill the entire pod. We do have some signal, but occasionally, if we don't handle very well, you maybe end up kill certain process in that C group, but the whole workload is not Kubernetes could be also don't get around to kill the entire pod. So you may paper over the real problem, but the customer maybe suffer. So all kind of those complexity. I think those complexity is being discussed even at earlier Kubernetes time. So hopefully this is why when the SIG version 2 come out, I hope we can do better job on that one. We have more signal from kernel, and we also they have the hop, they have the clubs, and we can pass in more during during the time we could trigger have the more control. Like user space can based on those like the our priority class based on how important the job it is, then we can pass those value to the kernel. I'm not sure the SIG version 2 can do that. Also, there's the one thing because based on our today's layout, no matter you are using the slice or using the old way system C group, so they always have the not reclaimable memory. So which is accumulative at the top level of the C group. So that's also make that node allocatable over time will be not representative at a given time. So there's the many complexity just share here.
Yeah, one thing sorry, go ahead, Eric.
You kind of detailed pretty well like what happens if you under reserve. I'm trying to understand the problem with over reserving, or maybe reserving for kind of what you would say is a bin packed node or fully utilized node, because I feel like if you adjust it, you're going to show that there's more resource allocatable, but then more pods are going to come in, and then you're going to have to reduce the amount of allocatable because system reserve would need to grow to grow. So it's almost like you would be falsely advertising that you have more, but if people do actually come on it, then you would start needing to take that away, and it would. I'm just curious what the downside of planning for worst case is, because worst case is maybe what you would be bin packing, like what your max pods would be.
So I guess for over reservation, then less resources, right, would be advertised to the scheduler, and less pods would be able to run on that node. And also the C group limit on the Q pods, right, would be lower, and basically you would be wasting some resources on the node because you're over reserving for the kubelet and the container runtime, if I understood your question right. I'm not sure.
Well, I suppose that in the scenario that your pod is your node is doing nothing, you have one pod on it, let's say, you're going to have too much space. That you'll be the system reserved will be have a lot of headroom, but nobody's there to use that headroom anyway. I guess my point is that if you are sizing it based on having zero headroom, like that you're at pod max with a set activity level for IO logs and stuff that might spike however much is used. If you just plan for that, I don't see what issue it have, because yes, when it's empty, it'll have, you know, extra headroom that could be consumed, but nobody's there to consume it anyway. If the node is completely full, you already know then that's how much system reserved you need for a full node. And you couldn't take any more in your size correctly at that point. So I'm just trying to point out that if you do reduce the amount of system reserved, you're leaving room for somebody who isn't there necessarily. And if you just have it set up for a full node, and that is correctly, that's kind of my question or point.
Yeah, I guess that makes sense to me how you said it. Yeah.
Daniel, there also have the one slide I remember you demonstrated. There's the sig-node and the same configurations, even same kernel version. If I remember, you mentioned some system identical, but it's just a different workload running. So you observe the memory usage is different. That's also could be the cases earlier, like Derek mentioned or Manu mentioned earlier. There also have some other thing. I also mentioned another thing like the could be not reclaimable usage, right? Accumulated. There could be another thing. It is today's situation. If customer like on certain node, they have the running job, and the user have to constantly send the kubectl execute and kubectl logging, which is also that's not a charge to. Unfortunately, today is not all charged to the pod. This is the accounting issue on the memory side, and also our code implementation for the containerd and the Docker. I believe CRAL also same cases. So still charge to the our node located to the system, and so that's also will bring some variety there.
I guess that's another point of why the cube and system reserved is not really determined to be able to be determined prior to the kubelet startup, I guess. So there's some variance there. What would make some sort of reconciliation, or at least being able to update it at runtime, handy, if I understood it correct.
You are so right. This is why no matter it's the kubeless reserve, those kind of node equitable reserve is the best practice, and also it is the best what we can share based on the production. So it's more like we generate those kind of things through the monitoring, and as the average. And so this is also like earlier we said that we cannot guarantee those things, because if we guarantee, then we have to enforce. You already mentioned that even when I enforce, you feel uncomfortable, right? So we just, because we, due to the limitation and the various cases, no matter it's in the kernel or user space. So that's why after this many years, unfortunately, we still didn't enforce those things. So if you say that I share something, and in the past we talk about, there's also have the formula. We talked about in the past, hopefully we could enforce, but until today, we feel we're still uncomfortable to enforce those things. Yeah.
So at least for the two questions, like this is a very interesting place for further study and learnings to the community. And at least you're not alone in knowing that others in the community, whether it's myself speaking from Red Hat's experience, or probably Dawn speaking from Google's experience, this ability to properly reserve is a community-wide problem. One thing I'm thinking about here is like if this is an area you'd want to do further study, or how hard it is to maybe tweak your setup, I would be curious to know if you did go and parent the kubelet and runtime in a different C group and did enforce node allocatable on the kube reserve C group only and not system slice, do you see different memory usage characteristics? Because the one thing I am thinking is that memory pressure on your C group will get reported at, I think, what it's 70 or 80% threshold value. I can't remember. And you'll start getting some reclaim. But as Don said, you might hit issues with things like exec and logging that might be variable in your real world environment. But I'd be very interested in learning on that. And then maybe Renal, do you want to talk a bit about why we think C groups V2 might be helpful here, or maybe some things that we're holding out for?
I think so with V1, the IO and memory aren't as well behaved. In V2, they have proper accounting between the two. And another issue we have really is like when you get memory pressure, like since we don't have swap, your executables will start getting, so the file pages will start getting swapped, leading to system instability. And like during recent conversations with kernel engineers, like they really said, oh, you cannot like totally pack it. You'll need to leave some headroom, and depending on your like workload characteristics, how much IO they're performing, how much memory they're requesting, you'll always need some headroom. So I think it's like you'll have to balance stability versus wasting some space for headroom. And to address some points, like Don mentioned about C groups killing some process in the pod. So in V2, we have a knob where we can say, oh, okay, kill at the C group level. So the whole thing goes away. So
we've been asked more than 10 years.
Yeah. So that will help. The second thing is with PSI, and like Ilana is working on swap. With those things in place, we'll be able to get in something like OOMD, and we'll be able to get earlier notifications and be able to take better decisions on what processes to kill. Rather than the killer doesn't work well at all under load. It'll end up like killing processes it shouldn't. You think it shouldn't be. And only way to protect against it is like setting a -1000, which you pointed out. One more thing, like I'm not sure, like on the cryo side, what we are doing is our shim, which is called conmon, is running under the pod slice. And so it gets charged to the workload, but it is also protected by a -1000. And we wrote it in C, so it doesn't have a lot of overhead. So that way we always get a notification, and also we are not like charging it to the system slice. So those are other things to play around with if you have like similar knobs on containerd side, and then use like the pod overhead feature to give your shim additional overhead if you need to.
I think what I didn't quite understand is how better accounting in the C group version 2 or PSI would help with that issue here, where you would need to, or where it would make sense to adjust the C group limits, for instance, for the QPod slice at runtime, because processes outside of it, like the container runtime, are using more suddenly. How is that related to that? That's what I'm trying to understand.
So there are a couple of knobs in C groups V2, like the memory high, min, and low. And there is a cap where we are kind of trying to use the min for the system slice, and then we'll see how it helps. The idea is like, as opposed to like the high and max, the pressure starts happening based on overage. And min gives you some like a higher level of guarantee that, okay, you won't get till you really start exceeding it by a lot. So there are some knobs, and we don't have all the answers right now, to be honest. And it's more like, okay, we got the basic C groups feature in place, which is at parity with V1. And now we are exploring the new knobs, and then we'll do performance testing and so on to drive like what will end up being the recommendations at the node level.
Yeah, I can add just in the 122 cycle right now, there is an open cap for memory QoS for C group V2 that's starting to explore using the memory.high and type of things to basically, induce memory take back right under system pressure. So that's something actively being worked on right now.
I also can attack why the memory accounting better can help this situation. So another beyond what Manu and David said earlier, So just earlier, I also mentioned like this is actually a user space problem, but we do have the same problem for kernel thread, right? So kernel take some behavior and to help certain part of workload container. Most it is charged to the container, but there still have some slab usage is charged to the kernel. So they will base on a different type of the workload. So all reserved for the system. And it could be based on those workload, could be not appropriate. So this is why dynamic adjust only based on number of the pod, based on those kind of things won't be accurate unless you have the better proper memory accounting. So this is from another perspective.
Okay, I see.
I think
Seems difficult.
Daniel, sorry, I'm going to have to stop you now. We have just 5 minutes and we have 2 more items on the agenda. So I'm going to have to hand over to Bartosz. Do we have him?
Yep, I'm here.
Bartosz, yep. Do you want to just quickly go through your item?
Yeah. Hi, everyone. So I just want to really quickly ask sig-node approvers to look at this PR, because it's ready like for a long time and it's got LGTM maybe months ago or something like that. So that's basically the only code PR that is related to this feature. The enhancement PR is already approved. So
hey Ed, I had a quick question.
Yep.
Did the so the tests look green. I don't see a PR for promoting the test to conformance test. Did that happen?
There is a PR for that, but I actually asked conformance guys on the Slack, and they say that this is not going to happen because this test requires additional hardware configuration, namely enabling 1 GB huge pages, and they are not going to allow that. So my idea was to promote it to node conformance, but I'm not actually.
I don't know if this is a node conformance thing because the node conformance tests are specifically for the CRI, and I don't know if this is a CRI specific thing. I don't think it uses a CRI.
Okay, so that seems that it's not going to.
I think it just
work
needs
either.
approval at this point.
Yep.
Yeah, so it's going to be hard to go from 2 meg to 1 gig huge pages and get that running in ED. I'll take a look at it, but I don't think that should block this.
Okay, thank you. That's it.
Thanks, Ed. We have Vinayak. I believe he wasn't able to join us. He has kind of his item pointed out there. People can have a look and look at the changes.
Yeah, I have some contact with that. I can give a brief introduce. Okay.
Cool. Yeah.
Yeah. Hey everyone. I'm Chuton. I reviewed Vinayak's cap. So it's about the security capability API we have in Kubernetes, and it has people know it has a add and drop, but the problem is the add doesn't work for non-root user in a straightforward way. So that's what it was about. The Vinayak proposed to fix this by adding the capabilities in the ambient capability set, which is a Linux concept. So in the original cap, he proposed to change the Kubernetes API by adding a new field, ambient, and also add a new field in the CRI correspondingly. And I talked with him. I kind of hesitating of changing the Kubernetes API in this way. So we think about the alternative that we reuse the current API, but changing the behavior in a transparent way. That is the current PL he mentioned in the notes. Container PL and CRI CRI-O PL. So we just changed the container runtime implementation. Yeah, that's just a brief introduction, and people can review the cap, can review this review these PRs. So I think he wants people's thought on if this is a better way, or we want to change the API. Okay.
I saw the PR and I left a couple of comments. I guess like we can figure that out async. Like basically the intersection with PSP plus and like a special case where a user does a drop all and then specifically adds back all the capabilities in the default set. So are we worried about things like that?
Sure. Yes, sure. And personally, I think we may want to clarify the spec. The current spec is kind of maybe not very clear, so we can clarify what will happen in different cases. Yeah. Okay.
I think both options were discussed before, but the actual field was preferred just because of the backward compatibility, right? Given the pod object, if we just change the meaning of add capability, it may cause some unexpected behavior. Like for example, there's a pod that a non-root pod, they have add some capability by mistake, and with this change, those capabilities will be granted to the node pod, cause some surprise to users because the behavior changed underlying. Although the new behavior is expected, I mean, it's the right behavior, but there's a behavior change to the existing pod.
Yeah, I see your point. I agree with you. Yes.
Yeah.
Okay. Any other comments, questions in relation to this item? Cool. I think we made it in time. I did see there was a lot of interest in Daniel's agenda item. So if there are follow-up items, we can follow up on Slack or maybe bring it up in the next meeting just to follow up the discussion. Thanks everyone for joining. See you guys next week.
Thank you, Swati, for hosting.
Thanks, Swati.
Thanks, bye-bye.
Thanks, Swati, for hosting today's meeting too. Thanks.
No problem. My pleasure, Dawn. Thank you.